All right, guys, let's go ahead and jump into these algebraic proofs. First of all, what is an algebraic proof? Okay, so algebraic is pretty much what it sounds like. It's algebra. So you're going to be solving, so solve equations with variables. Okay, so you're going to be solving equations with variables, and a proof is basically when you use information to verify if something is true or not. So we're going to verify if it is true, okay? So that's what we're doing. Let's go through these properties of equality. So these are I'm gonna write it over here. These are the properties of equality. Oops, there we go. Okay, so we first have reflexive. The reflexive property of equality is just saying that anything equals itself. Really simple. The next property of equality states that it's the symmetric, and it's just saying that if A equals B, then B equals A. If you flip them, it doesn't matter. That's all this one's saying. All right, next we have the transitive property. So if A equals B and then B equals C, then you can assume that A equals C. You could skip B. Okay, that's the, and now we have the addition and subtraction. These are the main ones we'll be using today. So if you know that A equals B, okay, so again, A equals B, then if you add C to both sides, it's still equal. You just have to do it to both sides. Same thing for subtraction. If you subtract something on both sides of an equal sign, you're good to go. It's still equal. Same thing for multiplication and division. If A and B are equal to each other, right, then if you multiply by something else on both sides, it's still equal. It just has to be the same thing. Same thing here for division. If A and B are equal, you can divide by the same thing on both sides, and it's still going to be equal. Next, we have substitution, and it's just when you replace something with something else. And then last, we have the distributive property. So that's when you're going to do this little number right here. So A times B gives you that, and then A times C, it gives you that. Okay, so that's what we're going to be doing today. Let's go ahead and jump into number 1. Given 3x equals 11, prove that that x equals 11 over 3. So we're just saying, okay, if this is the equation, then we need you to prove that this is x. So the first thing that I want you to do, is to write the original equation because it is given. You always start with the information that is given. Basically, we're saying the statement is 3x equals 11. The reason, well, how do you know? The reason I know is because it is given information. That's what we're doing in this 2-column proof. And then the next thing we need to do is solve. Well, since this is 3 times x, we have to do the opposite of times, or the opposite of multiplication, which is division. 3 divided by 3 cancels out, and then it leaves x by itself. And 11 divided by 3 is not a whole number. You could change it to a mixed number or a decimal if you want, but don't do that because this wants us to leave it as an improper fraction. Now, how did we get to this last step? Well, we divided by 3 on both sides, didn't we? That is the division property of equality. And that's all we're doing here, okay? All right, next we have number 2. So we have 2x plus 5 equals 22. That's our statement. We know that statement is true because it is given. So that's my reason. Next, we need to go ahead and solve this thing. So I see I have a plus 5 here. So I'm going to go ahead and take away 5 from both sides because don't forget you have to do the opposite in order to solve equations. That's going to leave me with 2x. That's going to zero out. 22 minus 5 is 17. All right, how did we get to this step? We had to subtract 5. That is the subtraction property of equality, one of the ones we saw above. All right, our next step, we see we have 2 times x, so we have to do the opposite of times and divide. So I'm going to divide both sides by 2, and 2 divided by 2, of course, cancels out. 17 divided by 2 is 8.5. How do we get to this point? The reason for that is that we use the division property of equality, and we are done because we got exactly what we wanted. If you notice, this time I left it as a decimal because that's what the prove statement said. You always start with given, you end with prove. Okay, oops. All right, so now we have number 3, which would be negative 10x minus 6 equals 64. We know that's true because it is given. So now we are going to go ahead and solve. So I see I have a minus 6. Let me go ahead and do the opposite by adding 6 to both sides of the equal sign. Then I'm going to bring down that 10x, negative 10x, excuse me. The 6 is 0 out. 64 plus 6 is 70. All right, so now, how did I get here? I added 6 to both sides. So I used the addition property of equality. All right, next step. I see that I am multiplying negative 10 by x, so I need to divide by negative 10. Always do the opposite when you are solving. So now the negative 10s will cancel, and x equals 70 divided by negative 10, which is negative 7. Well, how did I get to this step? Well, I divided both sides by negative 10. So that's the division property of equality. You do the same division on both sides. And we're done because we got exactly what we needed. All right. Next thing is number 4. So now we have 2 times 4x plus 2 equals negative 44. And we know that's our first statement because it is given. Oops, didn't mean to do that. Okay, so now we are going to go ahead and solve this. So if you notice, this has parentheses with a number outside, which means we need to distribute. So we have 2 times 4x, and then we're going to have to do 2 times 2. 2 times 4x is going to be 8x. 2 times 2 is 4. Bring everything else down. Okay? And we know that this step is true because of the distributive property of equality. All right? So now we're going to move on to the next step. I see a plus 4, so I need to do minus 4. So now I have 8x, my 4's will 0 out, negative 44 minus 4 is negative 48, and that was my next step. Oops. And I know that's true because I subtracted 4 from both sides, which is the subtraction property of equality. All right, next step is, since I'm multiplying x by 8, I need to divide both sides by 8 so that I can undo that multiplication. And I know that these 8's are going to cancel out because 8 divided by 8 is 1, and negative 48 divided by 8 is negative 6, which is exactly what I needed for my proof statement, so I am good to go. And I used division, the division property of equality to get here because I divided both sides of the equal sign by 8. Okay, moving on to the next one, number 5. So for this one, zoom all the way in because, oops, this problem is a little bit, it's going to be a little bit tough to get it in the box there. Okay, that wasn't too bad. All right, so now we have this situated. Similarly to the last problem, we're going to have to use distribution. 4 times 5, and then 4 times 8, and then 2 times 8, and then 2 times 22. So 4 times 5 is 20, so that's 20x. 4 times 8 is 32. Now over here we have 2 times 8, which is 16, so that's 16x. 2 times 22 is 44. All right, so now how do we get there? And actually I forgot to put given on my first line. Shame on me, shame on me. All right, now how did I get to the second line here? Well, I used the distributive property. Okay, so the distributive, you can put distribute, distribution, you get the point. All right, so the next thing that I need to do is, I see that I have x's on both sides. This is different than what we did before. If you have x's on both sides, find the smaller of the two, which is 16, and go ahead and take it away from both sides. So since 16 is smaller than 20, I'm gonna use that one and take it away on both sides. So 20 minus 16 is 4x, or it's 4, and so that's gonna be 4x. The 32 just comes straight down. These two are gonna cancel out, of course, or 0 out, and then that's just 44. How do we know that's true? Well, we use the subtraction property of equality. All right, next step. is that I see a plus 32, so I'm going to do minus 32 on both sides. Okay, and that's going to leave me with 4x. The 32s will zero out. 44 minus 32 is 12. And how do I know that? Again, I use the subtraction property of equality. And yes, you can use the same property twice. It's okay. All right, and last step is that since we're multiplying by 4, we need to divide by 4. On both sides, that will cancel out the 4's, leaving me with x by itself. And then 12 divided by 4 is 3. That's exactly what we needed to get, so we are good to go. And we use the division property of equality, right? Because we divided both sides by 4. Okay, moving on to the last example problem. All right, so now we have an equation with a fraction, and it's okay. I need you to breathe. It's just a fraction. All right, so let's start off with given, of course. All right, so now here's the magic trick for getting rid of fractions. You need to multiply by the denominator on both sides. The denominator is 2, so I'm going to multiply both sides of this equation by 2. So what that does is it cancels out the denominator. So now I just have 6x plus 10, and then 29 times 2 is 58. So how did I get here? Well, I multiplied both sides by 2. So that is, multiplication. That's the multiplication property of equality. All right, so now I'm going to move on. And it's just a regular two-step equation. So since there's a plus 10, I will do the opposite and do minus 10. So that's going to be 6x. That's going to zero out. 58 minus 10 is 48. Okay, so we just use the subtraction property of equality. And the last step we have is, not that though, is to divide by 6 on both sides, because we're multiplying by 6 right here, so that will cancel out the 6's, leaving x by itself. 48 divided by 6 is 8. So the last thing that we did was to use the division property of equality. Fix that V real quick, and that is all.